All right, Tanya is here with the topic of Agentic AI challenges and opportunity. She is a generative AI solution architect at Google, where she drives AI innovation and strategic programs leveraging technologies like Vertex AI and Kubeflow. Previously, she led machine learning initiatives at Crayon, specializing in LLMOps and cloud platforms such as AWS and Azure. As the former editor-in-chief of the Future Stack, Canberra's first AI newsletter, she helped shape AI throughout leadership. Tanya's experience spans across industries, including developing AI solutions for bushfire risk analysis and quantum decoders, as well as a strong academic foundation with a master's in machine learning and ANU. All right, are you guys ready to welcome our amazing speakers, Tanya? Let's give a big round of applause, yeah? Woo.
Wow. I don't know if I can live up to that introduction. Just give me a second. I'm going to join. Okay. Perfect. So today we'll be talking about AI agents, opportunities, challenges. So this is basically, a culmination of the things that I've been doing, the things that I've been learning. And I thought that we should have a chat about how to productionize agents. So this will be a very interactive one. I'll go forward, basically share some of the ideas, share some of the experience, and then I want us to question it, right? Like, let's have a discussion about it. So the question that I keep asking myself is, why right now? Like, why are we so hyped about agents right now? So one thing is, we've been trying to automate things for a long time, right? But right now, we do have the ability to reason at inference time, which is enabled by using reasoning LLMs. And agents, I see that as an extension of that, because when you have a multi-agent system, you're able to reason just much better. You're able to reason about many, many more things, but you're also able to restrict the context. So when you talk about context and memory and state, like these things which don't seem too tangible, but when you actually use them in a multi-agent system, they allow you to restrict the context. They allow you to sort of manipulate the context that you send to the LLM, which is very important. And that's one of the reasons it's a very, it's basically a good technology to be working on. The other thing is, of course, a lot of people are focusing on autonomy, but then the ability to build trust with the user. So how do you actually trust a system to do things on its own and still come up with a reasonable answer? That's something that's being solved by working on this in this area. Then we've seen a lot of human-in-the-loop agents with Copilot and Cursor and all these different coding copilots. I think that's also something that's driving innovation in this area, and that's adding tangible value to all of our workflows. Then agents, apart from doing autonomous goal achievement, we're able to plan better. We're able to use more and more sophisticated tools, like basically stack tooling on top of each other and carry out more and more complex workflows. Another thing I think is personalization, because we're seeing more and more systems that can handle, that can actually take the context and personalize it to a user's user's either chat or user profile, which is very interesting, and that's why like agents have that appeal. And the other thing which I'm very excited about is ability to improve over time. So I see that as a pinnacle of agents, at least till 2027, which is self-improving, highly autonomous systems that will tackle complex multi-step problems in dynamic environments. Okay, so let's think about building agents now. So basically, I've worked on two different projects. One was where there was no framework that was being used, because that project started last year, like Jan or Feb, and the other one used agent framework. So like the natural question is, why should you use agent frameworks, and when should you use them, or when should you not? So I would say, so personally, I would start with an agentic framework, because when you're building such systems, you need the ability to handle sessions. You need the ability to basically handle memory. You need the ability to understand, like, so when I say sessions, memory, I haven't introduced that, but I'm sort of guessing that, that's the common language that we all have. But yeah, like sessions, memory, managing context, like that's not a simple thing to implement. We could be implementing workflows, basically chaining LLM calls together, but sort of being able to handle that across a multi-agent system is not so straightforward. So I would sort of suggest starting with a framework. But then sometimes you need more fine-grained control over the context you pass to each LLM call, right? So the agentic framework might mask that. And it's not always easy to dive deep into that framework and figure out, okay, for this call, I want this, and for this call, I want something else. It's basically a framework. So you're plugging into the way it does things. So then if you need that fine-grained control, I would suggest maybe build your own first and then move on to the agentic framework. So yeah, these are sort of two different ways. Like in terms of agentic framework, when I say you can use LangGraph or Google ADK, that was just released 1 month back at Next. Yeah. Then let's move on to what are some of the challenges when you productionize such systems. So the first challenge that we sort of faced in one of these projects was the UX. When you say web app, we kind of know what a web app is. When you say an agentic app, either it can be a chatbot or it can be something that processes something, comes back to you. Like, it's not very clear, and everyone has to kind of decide that for themselves and their users. Also, the UX will decide how you build trust, how you sort of offer transparency to your users so that you are able to, just justify the decisions that have been made or the outcome that has sort of been reached on. So yeah, these are some of the things that are sort of challenging when you're building these systems. And also then there are the software challenges, right? Graceful failure handling, error handling. Also explainability is a big challenge. Yeah. Then reasoning brittleness, because LLMs, as we all know, can struggle with complex multi-step reasoning. Still, they struggle with that. And again, that reasoning will depend highly, highly on the context that you put. And I'll talk about that in the next slide. There's problems with reliable self-correction unless you have an Oracle data set, like this reasoning is the right reasoning. Unless you give that to the LLM, it's actually like very difficult for it to self-correct and arrive at the right reasoning. So that's another challenge. Since agentic systems rely so much on reasoning, right? Then context management, we already talked about that irrelevant or insufficient context, it degrades performance significantly. So ensuring that your LLM is, you're basically providing the right context at each call is essential. Then evaluation complexity, because, well, think about it, when you're building that agentic system, you have the tools, then you have some deterministic workflows probably, and then you have a planner that's probably going to stitch these deterministic workflows together. Now, evaluating that system is not as simple as, it follows the same paradigm that we've been using in software engineering, but then it has some other extra complexity that we'll sort of talk about. So that's another challenge. All right, so let's do a quick deep dive on context and reasoning hurdle that I just talked about. So basically, from some empirical studies by some papers from Google researchers like Denny Zhao, we have seen that LLMs reasoning really depends on the order of the context. It also if you ask it to self-correct the correct reasoning, it might actually arrive at the wrong reasoning. So these are some of the problems that we have seen while building these systems. So unless you have the actual Oracle data set, it's very difficult to say that, oh, this might be wrong, so can you correct it? And it would probably be a sick of it and correct it and arrive at the wrong reasoning. And some common failure modes that we have seen as a result of that are generating plausible but completely incorrect plans, making incorrect assumptions based on incomplete context, which is to say that it could have come back with saying that I don't have the right context to make this call or to basically, make the right assumption. Arrive at the right conclusion. And struggling with tasks requiring deep domain specific reasoning, which is like quite obvious if you have not sort of fine-tuned the LLM. So to get over some of these hurdles, what we try to do, and some things that I would sort of recommend based on some experiences, that try to start small and try to follow some of the patterns that work. These patterns are from the LangGraph documentation. There are a few in the ADK documentation as well, which sort of talk about multi-agent patterns. So sticking to a multi-agent pattern usually helps at the start because you sort of know what to expect, or you at least have some examples that you can start with, right? Then the other thing is, so while you're building these multi-agent system patterns, though, there might be issues like agentic handover, right? So handover is decided primarily using your prompts, because what you're saying essentially is, if this condition is satisfied, hand over to the next agent, right? So to tweak it is not as simple. You can add examples, you can make the prompt really clear, but sometimes it just doesn't get followed because there's context, there's so many other things. Then the higher the autonomy you have in your system, so basically the higher the less deterministic pathways you have, the higher planning and reasoning load you transfer onto the LLM, the more erratic the system can be. So that's something that can get tricky in these systems. Then, of course, testing is hard. So we try to start with test-driven development, start with unit testing the tools, which is great, like it's easy to do. Then testing the deterministic workflows, input-output testing, and then testing the trajectories. Like the way you can do that is my LLM using the right reasoning, taking the right action, using the right reasoning, and then using the right tool in the right order or not. So these are some of the things that we're using. And yeah, I think that's about it for this. One of the examples of a multi-agent system that I'm really fascinated with is the AI co-scientist. This sort of came back, I think, a few months back. And what this paper is about, it's like, actually, yeah, this works. Yeah, so basically what it does is takes a research goal, creates hypothesis, then reflects on it, refines them, puts them like against each other in a tournament-like fashion, then still improves them, and then even learns from all that, and then presents sort of scientific hypothesis based on your research goal, right? So the thing that I really like about that is the meta review agent, which analyzes all the interactions, all the context that has been produced as a result of this multi-agent interaction, and then finds out where it's not working properly, and then basically modifies the prompts of each of these agents to improve it autonomously. Like basically, it's basically doing what a developer would do, looking at the logs, analyzing what went wrong, and then modify the prompts. So yeah, it's like a good example of something that's self-learning in some way. Okay, let's talk about some evaluation strategies. So okay. So when it comes to eval, I think creation of metrics is a challenge. So right now, I've used mostly LLM as a judge metrics and basically trajectory-based metrics. Of course, you'll be collecting telemetry-based metrics, like what's the QPS and stuff like that, right? And you'll be like looking at latency and all those metrics. But LLM as judge metrics are really easy to start with and something that gets you going really fast. Then trajectory and tool evaluation, that again, we talked about that, like is the LLM or is the system using the right tool at the right time? Is the reasoning correct? So these are some of the things that you can use. The only problem is creation of a benchmark. It's very hard to create a benchmark when you have like first of all, if you have a data heavy system, so you're gathering a lot of data from your tools, it's very hard to create a benchmark because it's very difficult to simulate that data and then find out like if the right reasoning has been performed as a result of that, that data. So in that scenario, we sort of have been using a simulation environment where you have a user as an agent, and then it simulates a lot of trajectories, and then you sort of manually go through them with some assistance from an LLM and generate a benchmark, and then basically, create a synthetic benchmark using a user as an agent, and then sort of verify it and use that. Some of the other things that we've been working on is around red teaming as well. But yeah, I'm not going to talk about that today. Yeah, sorry about that. Then talking about observability and ops practices. So again, as Anupam also pointed out, that everything, basically building agents is not very different to what we've been doing. It's not like completely different. We're still following good practices. Observability, ops, still very important. It's actually more important because you kind of need observability into the reasoning as well as the decisioning of the LLM. And persistent session management is also very important. Otherwise, you won't be able to improve that. Like, there's no way for you to know how this thing will improve. And the other thing that I would suggest is rigorous hypothesis testing. So if you're building agents that you want to improve over time, one way that I've seen works really well is data-driven approaches that you look at, okay, what's not working, then create hypothesis, basically similar to what co-scientist was doing, but either in a team or automating that. So that's something that's like super exciting. And that brings me to self-improving agents. So I'm not going to spend a lot of time here, but again, some ideas. So paths to self-improving agents is basically how would you create a continuous improvement pipeline? So LLM assisted areas for improvement, then evaluating these changes against the metrics that you've established. So now you have a benchmark, you'll sort of evaluate these against the established metrics, and then roll out these improvements based on what the metrics say, right? Some of the key levers for this improvement could be fine-tuning models. So this involves trajectory fine-tuning. So if you have a good data set that tells your agent that this should be the right trajectory, that really works. But we've seen that work well with mostly self-consistency. You try out, you have let's say 12, 15 different checkpoints, and then you sample them a lot of times, and then you get the output that came out the most number of times. So that really improves the performance. And that's basically still pushing the reasoning or pushing the compute to test time. That's basically what you're doing artificially, right? Then context pruning and enrichment, that definitely helps. So making sure the context is just enough, not more than what the LLM might need. Very difficult problem to solve again, but that gives us a good boost. Then, of course, reinforcement learning based methods. Basically, we can talk about this paper that Google just sort of published. This is about basically using reinforcement learning to refine the memory. So this, I think it's called, I can't remember the name. Yeah, it's called reflective memory management. So what it does is, there are two ways that it refines the agent's memory. One is thinking of this interaction and then whether this interaction will be useful or not, like whether I can get something from this interaction which will be useful in the future. So that's like thinking forward. That's basically an LLM call. But the other thing is using the previous information, or let's say I have 10 sets of information with an agent, right? Gathering those, retrieving those based on my current query, and then seeing whether that information was utilized or not. And then if it was, giving that a better reward. And if it wasn't, like just giving a -1 reward signal. So that's how you sort of train the re-ranker. And I think such systems could do wonders, like such small improvements could do wonders for self-improving agents. Okay, I think I've covered this. Okay, yeah, so to finish off, so how do I see this road ahead? I think, yeah, experimentation is key. Constant literature review, hypothesis-driven development is sort of essential in this area. For for companies that want to, build more agentic stuff, investing in robust tooling is always, it's essential because you can have a reusable pipeline then. Prioritizing reasoning and context engineering because these are most impactful areas. And then starting small, just iterating on that, starting with simpler deterministic workflows and then moving on to more dynamic workflows. And of course, like I see that more collaborative and more complex agents would be built. And yeah, we'll sort of have to navigate the ethics and the trust explainability part of that as well. Oh, thank you. Any questions? Oh, yeah.
First of all, thank you for the talk. David, my question would be mostly about accountability and transparency of AI agents. As we know, like it's a very big concern that AI agents could divert from what they're expected or whatever their goals are.
Yeah.
And they may produce outcomes which are not necessarily expected. So my question was, although you did explain quite well about how AI models reasonings are like sort of explained through UI UX experiences, right? My question was, are there any safeguards from a governance perspective to make sure like whatever tasks AI agents are performing, they are like in line with whatever requirements they are expected to complete? And my other question would be, in case in cases where they do divert away from the goals, so who do we assign the accountability?
Yeah, it's a good question. So for your first question, I think there should be guardrails in multiple steps. The first one is the model itself, right? So while you're training the model, is the model following the goal or not? There's no way to know right now because even if the reasoning says it is, there are studies that say that it could be manufactured basically, right? So if you look into alignment research, that's what researchers are sort of figuring out. When does a model actually follow the goals of a human and when does it actually diverge to have its own goals? And that's like a very real possibility. It's not sci-fi anymore, right? Now, what's the impact of that? It depends on how you're using it, right? If you're offloading everything on the model, it could be quite huge, especially when it comes to self-improving agents and then just letting them run without any human intervention. Yes, it could have a huge impact, right? Then when it comes to guardrails, so the model gives you the output, like what do you do with the output, right? So there can be some guardrails at that point. I think that's where we can focus on. Most of the people who are working on applied AI, that's something that we can be focusing on. But yeah, from an alignment research perspective, I don't have the answer because like it's still under it's a very active research area. I hope that we have the answer. And then, sorry, did that answer your first question? Or okay, and the second one was, if something happens, who is responsible? Again, it's yeah, so I actually think the developer should think about what, like us, basically, we should be thinking about these things when we are developing it, right? So we work for a company, let's say we're working for a startup and we're developing this. Even if the legal responsibility does not lie on us as developers, we should be thinking about it. So that's my personal opinion. But from a legal standpoint, again, I'm not sure where that responsibility starts and where that ends, because of course, with a high agency, you could take all the responsibility and that could still not make a huge enough difference. So it's I think it's a very case by case basis. Yeah. Yes. Yes. Go for it.
What mechanism do you use for these agents to be self-improving? How do you make them self?
Some of the mechanisms that we talked about, like we can have the agent look at all the logs, identify where it's going wrong, either improve the prompt or improve the model, right? Or it could be as simple as just identifying. I mean, yeah, that's the high level sort of hypothesis improvement, finding out where it's wrong and then just improve it.
So the agent
Yeah.
figures out what it did
Exactly.
in the past.
Yes, yeah, that's where we are heading. Yeah.
So how does it know which is wrong and then which is right? So
Based on the logs, and then you have a benchmark as well. Like ideally you'll have a benchmark, you'll evaluate it. Also, you'll have some feedback. If the agent is in production, you'll have feedback from the users, so you'll figure that out. So based on the feedback. Yes. Yeah, sorry. Yes, please go ahead.
For the presentation, can you double click on just one mechanism, which is trajectory? Because that was quite interesting at this point of how does it work? What does it really?
Yes, like trajectory, using trajectories to improve, right? Okay, I'll show you a paper. So this is again published by Google Cloud AI Research folks. And we sort of worked on it in a use case. So this is basically creating synthetic data, so synthetic trajectories for an agent that was tested on SWE-bench, and the improvements were in using that synthetic data. You train fine tune basically a few checkpoints. So these were 12 to 15, if I remember correctly, and then using self-consistency. So it's just sample more and then find out the answer that's like the most voted, and then that's the final answer. So I could share this with you offline as well if you want. Yeah.
Is it very similar to something?
It's basically fine-tuning the LLM using those trajectories, saying that if the input is this, then you need to make a tool call. Or if, yeah, so giving the context, the entire context as the input till the next call. Yeah. Yes.
You were talking about workflows and agents, right? Can you tell me the difference between agentic workflow and AI agents? Because most of the time I've seen on YouTube, they're like, make AI agents in 5 minutes, and more or less they're just talking about workflows.
Yeah.
Can you tell me the difference between the workflows and the AI agents?
Yeah. So look, the definitions are quite interchangeable, but when I say workflows, I just say deterministic workflows. So you know what the next step is, one after another. The input of a particular node, the output of that particular node might change. Like it's probably not completely deterministic, but the steps are deterministic, right? When you talk about agents, the steps depend on the current input, right? So where the output of that particular call goes, it depends on the input and the context. So that's the autonomy, right? That's the planning part. Like, what should I do next is not fixed. Whereas in a workflow, from what I use workflow as, it is fixed. Yeah. Cool. Any other questions? Yes.
Is there any other use cases other than LLMs where agentic AI is being actively being looked into?
When you say LLMs, like, could you clarify?
Like, any benefit using agents? Yes.
I think it depends. Yeah, you could use agents in whatever way you want. Like if you're talking about computer vision, yeah, you could automate, let's say, looking at satellite imagery. Then, like, what's the next step? You look at satellite imagery. Maybe you want to identify where a particular set of water bodies are. You can just hand that over to some model. So what you could do, like, have a supervisor agent, which is an LLM, and then have like a bunch of tool calls, which are computer vision models, decide what to do with that. So yeah, you could use LLM as basically a junior developer deciding, okay, what should I do next, right? So yeah.
Right. More into like object detection.
Right. Like, you mean, can we use LLMs for that, or can we use agents for that? Again, depending on the use case, like what's the workflow, we'll have to sort of get into what's the workflow. If you're just saying, this is my input image, this is the output, and I have the bounding box and the object identified, like, why would you want to, I guess, right? Like, why would you want to use agents for that? Yeah.
I saw one paper by NVIDIA and Stanford,
Okay.
those researchers together, that these self-driving cars, when they go through the road, they see some signs, and some of them, for example, it looks like a stop sign.
Yeah.
But it's not really a stop sign. It's a stop sign part of an ad or like on the back of a bus. And in
Okay.
order for the car not to be confused, they use LLM. LLM doesn't know this is.
Yeah, that makes sense. Okay, so there you go. You have a use case. Yes.
Add to that, actually, sorry, I didn't mean to.
No, of course.
This is why we probably agentic workflow. The main idea actually came from the defense sector. The defense sector started 2 years agentic workflow. So the US drones that you see,
Yeah.
so they have the swarm drones. The swarm drone technology is based on agentic patterns.
Yeah.
Those agentic patterns were then brought in. So started to. So you have like a master drone, other drones, a goal, let's say attack someone, or go after something on the battlefield, it PHS and gives new instructions. So that went live, I think, 2 years ago. So there was a big feature maximum. So I think the AI is like we've seen LLMs, so a lot of the stuff that we do right now actually comes. Same thing with benchmarks. They started benchmarking.
Nice.
I was trying for a free method of Tanya solving the interesting use case I'm working on. So the bounding boxes thing that I'm working on,
Okay.
they're not actually accurate most of the time. So how would you increase the accuracy and could agents be helpful?
Okay, I'll have to think about that. Let's think. Yeah, let's talk after.
Thank you.
Awesome. Thank you.